Hey guys, welcome back. So today's video starts with a unusual behind the scenes look. So this is my point of view when I'm filming. I have my camera in front, which is powered from my DIY battery pack over here. I have my old smartphone over here plugged in with a USB charger. It can barely hold any battery charge, so that is why I have to have it plugged in. I have 1 and 2 LED light panels where each requires again 5-volt power. The light panels require 2 amp, and I also have my tablet. If the camera was in a position where I couldn't take a look at the screen, the tablet would sit in here. And because the camera and the tablet communicate over wireless LAN, this also means it uses more power. And that's where the problem starts. I only have 3 chargers, so I only have a limited amount of time, and therefore I'm going to build my own 5-volt USB charger, and this is the heart of it. And as you can see, it's 5-volt at 30 amps. I've chosen this power supply in particular because I want to have each USB port capable of delivering up to 3 amp, which means with a 30 amp power supply I can hook up to 10 USB ports. Now, standard USB devices only use between 2.4 to 2.6 amp. 2.6 amp is the highest current I ever saw. The standard is also in this range, so the 5-volt USB charging standard is in the range of 2.5 volt per port. More current you should not pull from port, but that's really determined by the device you plug into the USB port. So if I plug in my smartphone, the smartphone will determine how much current it will pull. And that is also why we can very simply hook up such a high current power supply with any 5-volt charging device, because the device determines the current, not the power supply. However, because the power supply is capable of delivering up to 30 amp, and in case something goes wrong, we need to limit the current. And for my project, I'm going to hook up multiple USB ports to this power supply, but each USB port will have a fuse. One of these. These are car fuses, and this one is in particular is rated for up to 3 amp of current. If you want to do this project yourself, you can choose whatever size power supply you would like to use. Again, I'm using 30 amp because I'm planning to have in the final version 10 USB ports. However, I only have 6 USB ports on hand right now, so it will be finished with only 6 ports. I also have a slight problem with the enclosure. Let me quickly show you. So I have chosen something that was laying around, and I did a whole bunch of things. What I ended up with was this over here. As you can see, I have only 6 cutouts in the enclosure on this side. And the reason is that I wanted to have enough space to properly hold onto each and every USB ports when plugging in or pulling the USB port out. And that is the reason for this big spacing in between. For now, I will only make this thing with 6 ports, but that doesn't change if you use more or less. Obviously, your power supply has to be appropriately sized. And if we take a look over here, you can also see that I have a hole in the front, and that is for the switch. So everything will go inside of this enclosure, and I will have the switch in front of here. And I can simply get this inside, so this is done as well. This is a very typical enclosure where you have first aid kits in your car. At least in Germany, you're required by law to carry a first aid kit. And that is the enclosure. They come in black, red, or whatever, and I decided to use this black enclosure because, for one, I had it laying around, and number 2, for me, it was completely free. Now, the power supply, I already prepared everything, will be screwed in like this. And then we also have our IC socket on the back for power in. It goes to the switch, from the switch to the power supply, and the power supply then distributes to the USB ports. And that's where we go next. So USB ports. I decided to solder the ports onto some perf board over here. This is actually the second iteration. First, I tried to have the fuses sitting between individual cables going to the USB ports, but I ended up with so much cabling and fuses just flopping in the breeze over here. And you have to keep in mind that we have some secondary and primary mains cable crossing one another, and that is just a hazard that I wanted to avoid. So properly installing the fuses in a certain safe place was a requirement. So my first idea was then to simply solder it onto the perf board. What we have here is positive coming in. We bond a second positive going to the next fuse, going to the third fuse, and after the fuse it goes into the positive slot of the USB port, and then we have simply hooked up all the negatives to one another. And I'm using these ring terminals so that I can screw it down to the power supply, and I'm not risking it well coming out of the screw holders over here. And yeah, so this works and it's totally fine, but if I ever blow one of these fuses, that's a pain to, well, replace. So the second iteration is this one over here, where I simply use some, how are they called? They are for cables, for cable ends, like these connectors over here, but they have these flat female connectors, and it happened to be that they perfectly fit fuses, so I can simply slot fuses in like this, and if one of them blows, I can simply replace them. So that's a big plus for this design, and also what I would recommend you do. However, it's not perfect because these are meant for cables. I had to drill holes, get them in, bend them, and then solder in place, and that's how it looks. But it's much better in terms of, well, repairability than this one over here, because here that's a huge mess if I ever have to switch the fuses. But to not waste this, I'm simply going to use this on the bottom, this one on the top, and yeah, so these are my USB ports. The way I mounted them is not perfect. I had to glue them down. I had to use some additional perf board underneath to, well, get them in the right height. In hindsight, it would have been better to manufacture these first, then get them inside and mark where I have to actually cut holes. I did it the other way around, where I first made holes in a way that I can comfortably plug in and remove USB ports. But, well, then I again had to use perf board and cardboard underneath to get the right height. And as you can see, these boards, they are not all at the same height. And for this one, I actually had to use some wire to make it more stable. But yeah, so if you do this, I recommend you make the distribution board first and then make the cutouts. That was just my stupid idea to make the cutouts first. Before I go ahead and install this power supply in the enclosure, there is a slight modification that I would like to make. Now, I went ahead and installed the power supply in the enclosure as well as the 6 USB ports, and as you can see, they are in place. Between each of these perf boards, these power distribution boards, I have standoffs, and I'm using 2 standoffs for the boards. Now, there is a slight design flaw. If we take a look and try to plug in a USB port on the bottom, you can see we have some movement on the whole assembly over here. But the bottom USB ports, they can be plugged in and unplugged, but the top ones, this is a design flaw. I have not accounted for this, and I just noticed it. For whatever reason, I thought the nylon standoffs and the mounting mechanism is good enough, but it is not. So what I have to do now is figure out a way to, well, prevent these USB ports from being pushed in. Okay, the zip ties saved the day. I now have, very hard to see, 2 zip ties installed, as you can see, and yeah, doesn't look too good, but it's all right. I made the mistake. That just can happen. So if you do this yourself, make sure that they don't move if you plug in and unplug USB ports. Now I have to say that these USB ports, they are new USB ports. They are very, very tight. Over time they will loosen up, but I don't think that they would ever be stiff enough. This portion will ever be stiff enough, even with the loosened up ports. So yeah, make sure that it's properly held in place. For whatever reason, this slipped my mind completely. I was more focused on the electrical design and stuff. Oh man, that was really difficult. So I just remembered why the switch wasn't installed. And that is, I still have to install the mains cables and everything, and I wanted to have a bit more plain cables. So I have this over here. This is a 3-wire, 3-core cable. We have our protective earth, we have our neutral and live. The same on the other side. No, this way around. So this will go in like this, and I will have the switch to these cables installed. This is our protective earth, and that directly goes to our protective earth connection on the power supply. PE is in place, and it's rather long cable. And then we have this cable in here. These need to be shortened and soldered, and this needs to be soldered to the switch, and that's what I'm going to do right now. So let's see how much. That should be fine. I was thinking about using, now that I think about it, I think I'm going to use some crimp connections for the switch side, and I'm going to solder the connections to the IC socket. And I have to do that because it only has solder points. So yes, they do fit. They're really tight, but they do fit. So these, I need 2 of them. They will be crimped on those cables. And there's enough insulation. Yes, it is. So, or rather, enough insulation removed. So the thinner part of this crimp is where we need to remove insulation. So this much bare conductor we need, and we do have plenty. Need to get them in here. Like this. Then the crimping pliers. Let's see, we have it in place. We can crimp. Now what I do always is get it back in and crimp another time, so that I have, or maybe even a third time, I move the whole thing up and down slightly, so that I have a very good crimp connection on this thing. And if everything went according to plan, it's not going to pull off. Yep, that's tight. Now this one can be installed. The cable goes in like this. Last screw, and then can go in like this. Just going to tighten every connection one more time to make sure that everything is properly installed. This is especially important for our protective earth, live and neutral. And done. The cables are now soldered in place. I used heat shrink on live and neutral, got some glue on the IC socket so it's properly held in place, and I almost glued my fingers together, and my nail polish is now not too good looking anymore. Glue and nail polish, they don't like one another. So this is how it looks, and yeah, we can now go ahead and finally test the USB charger. I'm so happy, and it looks clean. That's how it looks. Well, that's decent. Enclosure, IC socket, nothing. This has to be repainted. Doesn't look too good. That looks okay. Zip ties is not what I intended, but okay. And here we have our mains switch, and now let's test it. And with a bit of movie magic I was able to make it happen, and now the USB charger stays in place, and we can take a look at the voltage. 5.219 volt. Now let's see what is going to be the first test, and I think an LED panel would be nice. So let me quickly unplug one of the two LED panels. Now let's plug the light in. Okay, it's not powered on. We have this control over here. So it goes this way around. So power on. 700 milliamp at 5.133 volt. Let's go to maximum brightness. 5.07 volt at 1.529 amp. That is actually less current than I measured before. Well, I measured them before in cold state. Now they ran for the entirety of this video, so 3 hours. Wow. Now let's use another USB tester, and I'm going to use my electronics load. I'm not planning to actually blow a fuse. I'm going to... Interesting. Let's see, slightly below. Okay. Now let's go for more current, 2.5 amp, and we drop 300 millivolt. Yeah, that's decent. There isn't a single device in my possession that uses more than 2.6 amp, and I think the charger that would normally charge this device has a similar voltage drop. Now, before I end the video, let's quickly talk about why I built this thing and why didn't I buy something off the shelf. And the simple answer is price. This thing is so dirt cheap compared to what it can do compared to off-the-shelf products. The typical USB charger off the shelf that I was able to find is a charger with 3 or 4 ports, where only one port is fully capable of 5 volts, full capable 2.5, 2.4 or 2.6 amp, whatever the maximum current for the 5 volt charging standard is, and the rest, the other 2 or 3 ports are only capable of 1.5 amp each, and such a charger comes in at around 30 euro. Now let's talk about the price of this project. The power supply inside, the one I bought, and keep in mind this one is capable of easily powering 10 USB ports, cost 15 euro. Each of these USB connectors cost 20 cents. So for 10 of them that would make 2 euro. Main switch, this one comes in around 1 euro. The IC socket on the back comes in around 2 euro. The used fuses, 10 of them, 10 3 amp fuses, and these are used for cars normally, came in around €5. Add in an enclosure for maybe €10 and you land in the €40 to €50 range. Now think about this. This one has or can have 10 ports for €50, whereas you get 4 with only one really capable port for €30. I think you see why I built this thing instead of buying an off-the-shelf product. And also, this is a very simple project and makes a lot of fun. Oh, and before I end the video, one thing that I think I forgot to mention is the USB standard defines the resistance between data lines to be between 0 to 200 ohm for the device that is plugged in to detect that it's a capable charger. Otherwise it would only charge with 400 milliamp. But even just shorting the data lines only means that it is at least capable of 1.5 amp. For a device, for example a smartphone, to charge with more than 1.5 amp, you actually have to follow the specific phone manufacturer's detection. There seems to be a difference between certain phones, but all of my phones, they don't have this. They simply need D plus and D minus to be shorted, and they charge at full speed. So that's just something to keep in mind. I hope you liked the video, and if you did, please leave a like, comment down below, and other than that, thanks for watching, and see you next time. Bye!